So a few words about filler beam type of bridges. In this case, the steel is encasted. The encased steel beams act compositely with the concrete floor slab. The concrete transmits actions in compression, whereas steel acts in tension. We're using these in order to reduce the depth of the section, so we obtain a larger headroom for the vehicles. Furthermore, it also ends in a larger stiffness, so it's suitable for the strict code-based vibration and deformation rules. On the screen you can see the two models we're going to have a look at today. We have a 30-degree and a 15-degree bridge. The 30-degree one will be a grillage model, and the other one will be a plate model. As you can see, they both have the same dimensions, so it's 8.8 meter wide and 30 meters long. Here you can see a cross-section of the bridge. So the width of our sections are 0.6 meters and the depth is 0.67 meters. Also here you can see the reinforcement in them. At the top we have 4 P20 reinforcing bars, and at the bottom we have 2 P16s. Okay, so now I'm going to move on to the software itself. So this is the MIDAS civil interface. At the top we have the ribbon menu, which contains a variety of tabs. All of these tabs are positioned in a logical order to aid the engineer in their everyday project procedures. In the structures tab we can define different structures. Nodes and elements tab we can define the geometry. Then we can assign different kind of properties, account for the boundaries, then apply loadings, carry out different types of analyses, then extract the results, and finally we can do different types of designs and generate the report for this. On the left hand side we have the tree menu. You can see one of this on both the left hand side and the right hand side. In the works tree you can see everything that has been defined so far. Right now this is empty, as I have started an entirely new project. And you will see this being built up as I go along with the modeling procedure. So I will start off with the definition of materials. So click on material properties, add. Here you can add different type of materials by defining the standard and database. However, in order to save some time, I'm going to bring these in from a previous model. So just import and just bring this in. You can do this if you have any of the materials or sections defined in previous projects. You can just bring these in without having to redefine them again. Okay, so as you can see, just in a matter of a few clicks, I have my materials, sections, and the thicknesses. We can right click on any of this, go into properties, and here you can see the standard and the database, also the material properties. Similarly for sections, you can right click on this, go into properties, and here you can see that this is a user defined section with the parameters as shown below. Also we can check the calculation results, so here are all the section properties. Finally, you can see the offset. So this section will be offset from this reference point. Okay, so I will move on now onto generating the model itself. So first I'm going to create a node. Just create node and press apply. In this case I have generated a node in the origin. From the top view you can see the node over there. Using the select single tool, I'll just select this node and I will extrude this into a line element. So we have our transverse element. I will use the extrude function. In this case I will be extruding a node into a line element and by an unequal distance and into the y direction, as you can see it on the screen. Okay, so now I'll just input my parameters for this, 0.3. And by pressing apply you can see that the software has generated the first these elements. Now I'll just turn off the hidden view, so I will work only with the mathematical model. In order to account for the skew, I will select all these elements and rotate these. So go on to rotate, move, and just input the angle by which we're going to rotate it, and define the axis about which this rotation will take place. So just press apply, and now you can see that this has been rotated. Next, I'm going to generate all the longitudinal elements. So again, just select everything and extrude. I'm going to be extruding node into line elements, and because I'm generating the eye sections now, this will have the steel material and the filler beam section, and this will be at an equal distance of 0.5 and 60 times. So that means we have a 30-meter long bridge. By pressing apply, you can see that this has been generated. Also at this point I can turn on the perspective view, and by rotating the screen you can see that we have our eye sections over there. Okay. Next, moving back to the top view and taking off the perspective view, I will select the same line by clicking on select previous, and in this case, in order to generate the concrete around these beams, I'm going to generate plate elements. So just go on to line element, into planar element, and these will be concrete, and they will have the same parameters. Okay, so by pressing apply, I can turn on the perspective view now, and we can see that now we have our concrete around the eye girders. Okay, as you can see it on the two edges, we have the steel eye girders which are not encasted into the concrete. So these I'm going to assign the section properties of the left parapet and right parapet beams. So for that, just go on, take off the hidden view and just select the elements at the top. These will be the left parapet beams. However, before I assign these, let me just turn on the hidden view so you can see how the section the elements changed the section. So just simply drag and drop left parapet beam onto the screen, and you can see how this has jumped up and changed sections. Okay, similarly for the bottom part, right parapet beams, and turning on the hidden view, you can see that we have our entire model generated. Okay, so as a next step, I'm going to assign the boundaries. So I'll just take off the volumetric view and go on to boundaries, and I will be defining supports. So the supports will be on the two ends of the bridge. For this, I will use the select by polygon to select the nodes at the end, and I will be restraining these nodes into all the dx, dy, and dz directions, so it means that these can't displace in these directions. By pressing apply, you can see that the hexagonal shape has appeared. This represents the 6 degrees of freedom, as you can see it in the dialog box as well. Next, I will do the same procedure on the other side, except that the supports are going to be different. In this case, I will just restrain it for the dz. Okay, so by pressing apply, you can see that these have been restrained as well. Next, we can move on to the loadings. So load. First, I need to generate the load cases. So for that, go on to static load case and just input self-weight. Self-weight will be a dead load. Add. Next, surfacing. This will be a dead load again. And finally, the parapet. Again, this will be a dead load. Okay, so I can close this dialog box down, and now you can see that we have our 3 load cases. Next I will be assigning the loads to these. So for self-weight, I'll just select the load case as self-weight and input -1 for the Z, as the gravity will be acting downwards. Okay, so by adding this in, this is sorted out. Next, I'm going to apply the surfacing. So for the surfacing, this will be applied onto plate elements. So I'm going to apply pressure loads. I'm going to simply select all the plate elements and then just go to pressure loads, select surfacing as a load case name, and apply this in the global Z direction and just input the value. This can be uniform or linear loading. As you can see it on the drawing over here, this is a linear loading, as different nodes have different pressures on them. Okay, so by pressing apply, you can see that the loading has been applied onto all the plates. Next, I will be applying the let me clear the screen by the initial view. Next, I will be applying the parapet loads. So for that, just select both sides and then go on to element beam loads, select parapet as the load case name, and just simply input -1 kN per meter. By pressing apply, you can see that this has been applied onto our model. Okay, I'll go into initial view again. So now that we have our boundaries and static load cases, we can move on to the moving loads. So this can be done in the load, moving loads. First, we need to define the moving load code. So there will be Eurocode. Because we have plate elements, we're going to apply traffic surface lanes. Add, and here we just need to input the name of the lane, then specify the lane width, the wheel spacing, offset, and the skew angle of this. Okay, and next we're going to select 2 points. These 2 points are going to define a line from which we have this particular offset of -0.9 meters. By pressing apply, you can see that we have our first footway. Next, I will do the lanes, lane 1. So this will have different parameters. For lane width 3 meters, wheel spacing 2, and with a different offset. Okay, so now I'll just delete this information and define the line. At this point, we can save our model, save. So I'll just define the line from which we're going to have our new offset, and by pressing apply, you can see that this has been generated. Similarly for the other lane, just input the new offset and generate the line of reference, and then finally press apply. As you can see, we have our second lane, and then finally the last footway with different offset, and again just simply define the line of reference, and then by pressing OK, you can see that just in a matter of a few clicks and minutes we have all of our lanes. Next, I'm going to define the vehicles. So just click on vehicles. As you can see, we have standard vehicles or user-defined vehicles. Today I will add standard ones for LM1, and as you can see, we can define the adjustment factors, apply. Then I will have an LM3 with the UK National Annex, an SV80, apply. And finally, I will have a footway loading, and just press OK. Okay, so here you can see that we have our 4 lanes and our 3 vehicles defined. These are blue right now because they are not connected to each other. In order to connect them, we need to generate the moving load cases. So for that, just go on to moving load cases, add, and here just input moving load case 1, just input the name, select the load model, in our case it's LM1 and footbridge, and defining the load case data, so applying the footway loading, and then assigning the lanes. So we're going to assign all the lanes in the selected lanes first, and for the 2 footways we're going to take these into the footway lanes. Okay, so by pressing apply, you can see that the first moving load case has been generated, and also all the lanes now have vehicles assigned to them. We're going to have another load case for this, moving load case 2. This will be an LM1 and LM3 multi-straddling one. We're going to ignore the side factor in order to turn this into a leading variable, and for LM3 we need to specify the loading, and also we're going to make this straddling, so just simply select the 2 lanes and add this in as a straddling lane. By pressing OK, you can see that this has been appeared both in the dialog box as well as in the worktree. Okay, so now that we have everything defined, we can move on to analyzing the model. In order to save time, I have already analyzed this model, so let me just take that over. So here you can see that everything is the same, so all of our load cases and the lanes are the same. What I'm going to do now is have a look at the results. So we're going to start off, let me clear the screen first, display. So I'm going to have a look at the reactions first. For the FZ due to self-weight, and we can have a look at the values and the legend. By pressing apply, you can see the software has displayed all the reactions, and also it has highlighted for us the largest reaction. Also in the right hand side in the legend you can see where the maximum and where the minimum values are. You can see this, you can check this also in a tabular format. So you can click on the 3 nodes and just simply select self-weight or any of the other load combinations that you're interested in. By pressing OK, you can see that the values for these are shown. Because our tables work the same way as Excel, we can just simply sort these. So we can right click on this sorting dialog, and then we're going to sort for FZ. So just take that over to the other column, and as a priority I'll just take this up. So by pressing sort, you can see now that we have this in an ascending order. So we have the minimum at the beginning and the maximum at the end of the table. Okay, so let me close this down. Next we can have a look at the deformations. So displacement contours, and let's see the deform shape. Okay, so here you can see how the model is going to deform. In MIDAS Civil we can change the units whenever we want. So we can change from meters to millimeters, and as you can see the software has updated the outputs for this. We can check for different load cases, as you can see, and we will have the different outputs. Next, let's have a look at the forces, so beam force diagrams. Due to, let's see, moving load 2, and with a solid fill. Okay, so when I press apply, this is displayed. On the right hand side you can see the maximum moment. This can, at this point we can change the units into meters. And as you can see, the software has updated this. Okay, so here we can also check the element for which we have the maximum bending moment, so that's 522. And from the influence surfaces we can check the influence surface for this particular element, so just input the element number and press apply. And here you can see the influence surface. Okay, Similarly, we can, using the moving load tracer, we can check the results. So the moving load tracer is going to show us the most severe positioning of the live loads onto this element. In this case, you can see that the vehicles are how the vehicles are positioned, so the SV80 and the other ones, and also you can see the influence lines on the right hand side, influence surfaces, and you can see the maximum value of the moment on the left hand side. Furthermore, this can be turned into a static load case, and for that we can check the coexisting forces. Okay, so finally, let me just clear the screen. Finally, we can have a look at the stresses. So, for example, the plane stresses and legend apply. So, as you can see here, these are the plate stresses. We can again check the change the units. So we can check these in megapascals. Okay, so we can check for the axial stresses, shear stresses, and so on. And finally, moving on to the design, we can carry out the design for the steel element, so the steel I-beams. So for this, we can choose the code, specify the partial factors, modify the steel material as well as the serviceability parameters, and then we can carry out the steel code check. So at this point, the software checks all of our steel elements. As you can see, this came up as red, so that means it didn't pass. We can select this, go onto graphic, and here we can check the results. On the right top corner, you can see the section itself, along with the design information, member forces, design parameters, and finally in the checking results, you can see that it fails under the combined resistance. So in order to sort this out, we can just select the element, go on to change, and here we can specify different parameters in accordance to which the software is going to search for sections which will make this design pass. So in this case, I'll just input, let's say, 0.62 meters for the depth of the section, and by clicking on search satisfying section, 620, search satisfying section, we can see these are the sections we could use. So let's choose this one, as it has the highest efficiency of 99%. And now we can just click on change and close. And at this point, the software is going to replace all the steel members with the one that we have selected, and going to carry out the design checks for this again. Okay, so as you can see, now it has turned blue. So for this, we can have a look at the detailed design and the detailed output. Here the software shows us all the load combinations together with the steel code checking information, as well as the classification of the flanges and other checks, if they pass or not. Okay, so let me close this down. Okay, so moving on to the other model. In order to save time, I have already defined the geometry. So as you can see it over here, let me turn on the perspective view. We have our edge beams and our main girders, along with the truss element, the transverse element. Here, if I select any of the elements, you can see that these are not plate elements but beam elements. So let me unselect that. The reason why I have not defined the longitudinal section is because I'm going to show you how to generate this, how to generate the composite section from scratch. So let's start off with looking at the works tree. So we have 4 materials, 3 sections, out of which one I'm going to show you how to define soon. We have 3 types of supports. 2 of them are identical to the ones defined in the previous model, so as you can see for DZ. And finally, the last one I have generated in order to account for the construction stages. Because we are going to have construction stages, in the first construction stage, only the longitudinal elements are going to be activated. In order to restrain these into the dy direction and also the rotation for Rx, we needed these supports. So these supports are going to be activated in the first construction stage and removed in the second one. Okay, so for the static load cases, we have the same ones as before, except that in this case they are element beam loads instead of surface loads, pressure loads, and also the traffic line lanes. These, instead of being surface lanes, these are line lanes. Okay, so let me just undisplay this and let me show you how to define the composite section. So for that, I'll go into Tools, Section Property Calculator, and here just simply select newtons for force. Okay, here, because we are going to have a composite section, we need to define the 2 materials for this. So starting off with the model, material, add. So we're going to have the steel, which is 200,000, and just simply input the other parameters, apply. So concrete, for this input the parameters, okay. So by pressing apply, you can see that the 2 materials have been defined. Next, in order to save time, I'm going to bring in the model from AutoCAD. So File, bring in from an AutoCAD DXF file. So just select the file, open. Okay. So here you can see the section. The steel I section is represented by lines, to which we're going to assign widths, and the concrete is represented by an enclosed area. So starting off with generating the 2 parts of the composite section, generate, name it composite. This will have 2 parts, and the base material will be the steel. By pressing apply, you can see that this has been generated. Okay. Next, I'm going to add in the 2 parts. So add part. The first part will be the steel. This I will select by lines, and here just by pressing Ctrl, simply select. Sorry, first I need to account for the widths. So just go into curve, change width, and just select the lines and input the width for this. Apply. So similarly for the web, apply, and for the bottom flange, apply. Okay, so now we can do the add in the 2 sections. So add part, it will be steel by line selection, and just simply by pressing Ctrl, select all the steel parts, press apply. At this point you can see that this has been generated. Next I will add in the part for the concrete. So concrete, this will be by plane, and for that just simply select everything and unselect the steel parts. Okay, and this will be the concrete material. By pressing apply, let me just, no, this will be part ID 2, and now let me select this again and press apply. Okay, so we have our two parts added. At this point we can calculate the composite properties. Just input the mesh size and select the section, just press apply. As you can see, the properties for the composite section are have been calculated. Next we can check the properties, so for the steel, the concrete, and for the steel and the concrete together. Finally, we can export this, so from section, composite section, export, just select the section and add in a name, let's say tutorial, yes, and by pressing apply, this has been exported. Okay, so I can close this down now, and in main MIDAS we're going to properties, section properties, and we'll add this in here. So add, this will be a composite and composite general. So for the name, let's say main Girder, and import file, and here the tutorial that we have just done, open, and by pressing OK you can see that this has been done. Also at this point you can just click on calculate section properties, and these will be recalculated for you. And also let's assign the offset, so this will be center bottom. Okay. By pressing OK you can see that the main girder has been added in. Now we're going to assign this to the longitudinal element, so just simply drag and drop main girder onto the screen. Okay, so at this point you can see that we have our eye sections with the concrete around them, and the model is completed. Okay, so next I'm going to generate, let me take off the node. So next I'm going to generate the construction stages. For that, just go into load, construction stage, define construction stage. Here add, and starting off with this first one, the main girders will be added in. At this point we're going to have both of our supports in order to account for the lateral movement and the rotation of the main girders. And for load we're going to have the self weight. Okay, so by pressing apply, our first construction stage is done. So for the second one we will have the parapet and the cross beams added in. For boundaries we're going to remove the temporary supports, so add that as the deactivation and press apply. For the third stage we're going to have our parapet loading added in, apply, and for the fourth one we're going to have the surfacing. Okay, so next we can generate the composite sections for construction stages. So in order to tell the software that we're going to have the I-beam first and then we're going to have the concrete around it, we need to add this in. So the activation stage will start at CS1. The material type will be steel first. This will be activated in stage 1. And for the second part we'll have material with the concrete, and this will be added in the second stage. By pressing OK you can see that this has been added in. And also at this point we can have a look at the composite interaction. So let me just rotate the bridge, and for construction stage 1, let's zoom in a bit. So you can see we have the steel sections here, then we're going to have the concrete around it together with the parapets, and then in the other stages we're going to be having the additional loads. Okay, and finally we're going to define the reinforcement. So for that, just go into Properties, Section Manager, Reinforcement, and here we're going to add the reinforcements for the main girders. We can define a guideline, so this will be the cover. The input method will be B, and just specify the point, the beginning and the end of the reinforcement. The number is going to be 4. We'll have this at the edge bar, and the size of this is P20. Okay, so we can add this in. Similarly for the bottom part, we're going to have 2, which will be P16. Add this in, and we're going to have the other ones on the other side. Okay, so add this in. I've just noticed we're in a construction stage, so let me just go back into base stage because that's where we can add in the reinforcement. So let me just do this quickly again. So here, add in the guideline as 0.05 meters for the cover. Choose input method B, and input the number of reinforcements. These we're going to have at the edge, and for the size of these we're going to have P20s, and we're going to add these in. Okay, so next we're just going to have the bottom part. This is going to have 2 rebars, and these will be P16. Add, and similarly on the other side, add this in, and finally by pressing apply you can see that this has appeared in the works tree. Okay, so I can close this down now. At this point we have everything defined, so let me move on to my final model. So let me just take this over. Okay, so here we can again have a look at the results. So as we have seen the post-construction stage results in the previous model, in this case I'm going to look at the construction stages. Let's start off with the displacement, and let's see for summation. Okay, so we're looking at the legend and the deformed shape, and let's turn on the perspective view, apply. So as you can see over here, this is how our bridge is going to deflect. Again, the units can be changed if you want to, however this is not a must. Also we can have a look at the forces, so beam forces and diagrams with a solid fill and without the deformed shape. Okay, so let's see this from the front view. So these are our moments, and we can check this in each construction stage. Okay, and let's have a look at the post-construction stage as well. So this is due to moving load case number 1, and we can check it for moving load case number 2 as well. Okay, we can also have a look at the stresses. So beam stresses, these stresses can be checked for both parts of the composite. So let's see at part 4, for part 1 and at point 4. Okay, so these are the stresses. Again, we can change the units. In this case it's more suitable. So now that we have megapascals, You can see the values over here. And finally, you can have a look at the moving load tracer. So I can just go on to initial view, moving load tracer, and for beam forces a moment, let me take off the perspective view. At this point we can choose any element, press apply, and the software is going to position the live loads in such a manner so that this gives us the worst loading case. Okay. So as you can see, we have our SV80, our vehicles, and again this can be turned into a static load case, and the coexisting forces can be checked for this. Moving on to the design, so let me go on to the top view, design. We can perform the design for this as per the Eurocode. We can define different parameters for this, the gamma factors, the design materials, longitudinal reinforcement. However, what I have defined, especially in this case, is the flange and web. Because this is a value type section, the software doesn't know which part of the steel is the top flange, web, and the bottom flange, so we have to define this. All we need to do for this is just select the part, choose whether this is top, web, or bottom, input the part name, and then whether if it's outstand or internal. Okay. And finally, we can carry out the design for this, which I have already done. So we can have a look at the bending resistances, for example, and here we can see all the results. Again, the units can be changed, and this can be sorted for whichever value you would like to. Okay, so let me close this down. We can also define the design position. So the design position defines for which elements we're going to carry out the design. So in my case, I have done this for the main girder at the center, and also we can define the output position, for which we're going to obtain a complex Excel spreadsheet. So let me show you that. This has been done for element 1301. You can see the design conditions, the material informations, and the checks over here. So you can see whether this is okay or not. Okay, so let me close this down. And finally, we can generate the dynamic report. So for this, just go on to dynamic report generator, press OK, because we're generating a new one. So in this case, a Word document will be opened up. This can be either a plain Word document, or you can have your company template already applied onto this. And I have previously taken some pictures. So for this, you can just double click on the picture, and it takes you to the to the point where I have taken this. So as you can see, this is the deflected shape and in construction stage 1. Okay, so I can go on to report editor, and I can just simply drag and drop this onto the report phase, and the software is going to implement this. Similarly, for any other pictures, you can just simply drag these in. Okay, the same applies for tables. So you can take a dynamic report image of any table, and you can put this into the final report. This is going to be in a table format, so you can edit this, you can add in or remove if you wish. Okay, and similarly, you can add in any section summaries, reinforcements of sections, and so on and so forth. And if anything changes throughout your meetings, you can change your model, reanalyze this, carry out the design, and then just go on to dynamic report auto regeneration. and you can automatically regenerate the report for this. So just simply specify for which part of the report you want to do the regeneration, and then you can regenerate this, and all of the informations will be updated. Okay, so that's the end of my presentation today. Thank you for your attention. If you have any questions, you can send these to UK support at midasuser.com or put these into the chat box. Thank you for your attention. Goodbye.